Hello, my dear children. Today we are going to discuss exercise 2.3 concepts. In the chapter Relations and Functions, we are going to discuss the concepts or points in the exercise 2.3. The following 3 points we discuss these following 3 points in this exercise. These are very useful for the exercise 2.3. Okay, my children. The first point is function. First of all, we define a function. What is meant by a function? And second one, real valued function and real function. We define a real valued function and what is the definition of a real function. Okay, my children. Now, third point is some functions and their graphs. Here we discuss some functions. See these 7 functions. These are very useful in future also, my dear children. Listen carefully. Identity function, constant function, polynomial function, rational function, modulus function, signum function, greatest integer function. We discuss these 7 kinds of functions and their graphs. Okay, my dear children, are you ready to listen the class? Right. Now the last point, the last concept of this exercise 2.3 is algebra of real functions. Under this concept, under this point, we are going to discuss these points: addition of two real functions, subtraction of a real function from another, third, multiplication by scalar, next fourth one, multiplication of two real functions, and fifth one, quotient of two real functions. Okay, my dear children, right. Now come to the first point, my dear children, that is function. Here we are defining the function. Okay, my dear children, a relation f from a set A to set B is said to be a function if every element of set A has one and only one image in set B. Understood this definition, my dear children? Function is also a particular type of relation in which, see here, every element of set A has one and only one image in set B. It means if you draw an arrow diagram, from every element of set A, one and only one arrow should be drawn to the elements in the set B. Okay, my dear children? Right. In other words, a function f from a non-empty set A to a non-empty set B such that the domain of f is A and no two distinct ordered pairs in f have the same first element. If you write the function as a set of ordered pairs, in that case we have to use this definition. If we distinct ordered pairs are taken into consideration, then we have to check whether they are having the same first element. If they have the same first element, then that relation is not said to be a function. It is only said to be a relation. Okay, my dear children? Right. There are many terms such as map or mapping used to denote a function. We can use map or mapping instead of the term function. Okay, my dear children. Suppose f is a mapping from A to B, then it is denoted by this notation. F is a mapping from A to B, and it is read as f is a function from A to B, or f maps A to B, or f is a mapping from A to B. In this way we read this notation. Okay, my dear children, understood? Right. If f is a function from a to b and ordered pair a comma b belongs to f, then f of a is equal to b, where b is called image of a under f and a is called the pre-image of b under f. Understood, my dear children? Suppose ordered pair a comma b belongs to f. I represented this relation in the arrow diagram like this, a to b. Suppose a is an element in the set a and b is an element in the set b. So there is a relation between a and b. So here a is said to be pre-image of the element b under the function f, and b is called the image of a under f. Okay, my dear children, understood? Right. Now come to the next point. Second point, real valued function and real function. A function which has either or. Here or denotes set of real numbers. Okay, my dear children, understood? Either or one of its subsets as its range is called a real valued function. Okay, my dear children. Further, its domain is also either or denotes a set of real numbers. Remember this point, my dear children. Or a subset of or. It is called a real function. Understood these definitions, my dear children? Throughout this chapter, we study real functions. Okay, my dear children? Right. Now come to the third point, that is some functions and their graphs. Under this point we discuss identity function. First function is identity function. Let R be the set of real numbers. Define the real valued function f from R to R by y is equal to f of x is equal to x for each x belongs to R. Such a function is called the identity function. So y is equal to x or f of x is equal to x. If a function is defined like this, such a function is called an identity function. Here the domain and range of f are real numbers, set of real numbers. Okay, my children, the graph is a straight line as shown below. It passes through the origin and it is inclined at 45 degrees with positive x-axis. If you draw the graph of this identity function, it is shown in the figure given below. If you observe that graph of this identity function, it is passing through the origin and it is making an angle of 45 degrees with positive x-axis. Okay, my dear children? Right. So this is the graph of the identity function. This is a straight line. It is passing through the origin and it is making an angle of 45 degrees with positive x-axis. Okay, my dear children, remember these points, my dear children. Definition of an identity function and graph of an identity function. This knowledge will be useful in your future also. Okay, my dear children? Right. Now come to the next function, that is constant function. Here we are defining the constant function. Define the function f from R to R by y is equal to f of x is equal to c, comma x belongs to R, where c is a constant for each x belongs to R. So y is equal to c. It may be any constant. C value is any real number. Here domain of f is set of real numbers and its range is singleton set C. Only one element is there in the range of the function f. The graph is a straight line which is parallel to x-axis. This is a graph of a constant function. Suppose y is equal to f of x is equal to 2. It is a constant function, graph of the constant function. It is parallel to x-axis and it is at a distance of 2 units from the origin. Similarly, here y is equal to f of x is equal to minus 3. It is also a constant function, no variable. Okay, my dear children. The RHS, now there is no variable. So, it is also a straight line parallel to x-axis at a distance of 3 units from the origin but below the origin. Understood, my dear children? Right. Now come to the next type of function, that is polynomial function. A function f from R to R is said to be polynomial function if for each x belongs to R, y is equal to f of x, that is equal to a naught plus a1x plus a2x square plus and so on an x power n, where n is a non-negative integer and a naught comma a1 comma a2 and so on an belongs to R. These are all real numbers. Okay, my dear children. The functions defined by f of x is equal to x square plus 2 and g of x is equal to x power 4 plus root x are some examples of polynomial functions. You have already studied about polynomials in your 9th class and also in 10th class. Y is equal to, if any polynomial is given, then the function is said to be a polynomial function. Understood this definition, my dear children? Right. Now come to the next type of function, that is rational function. In 8th class, 9th class and 10th class you have studied rational numbers. Rational numbers means the numbers which can be expressed, which can be written in the form of p by q, where denominator should not be equal to 0. The same definition can be used here. Instead of numbers, we are taking the polynomial functions in the numerator as well as in the denominator. Rational functions are functions of the type f of x by g of x, where f of x and g of x are polynomial functions of x defined in a domain where g of x is not equal to 0. Here denominator is g of x. It should not be equal to 0. Numerator and the denominator both are polynomial functions. Then f of x by g of x. This function is said to be a rational function. Understood, my dear children? This part is very important in finding the domain of the rational function. Okay, my dear children? Right. Now come to the next type of function, that is the modulus function. We are defining here the modulus function. The function f from R to R defined by f of x is equal to modulus of x for each x belongs to R is called modulus function. You have already studied about modulus of a number. It is also called absolute value of a number. This is called modulus of x, absolute value of x. So this function is said to be the modulus function. We define like this: f of x is equal to x for every x greater than or equal to 0, and f of x is equal to minus x if x is less than 0. Remember this definition, my dear children. Okay. Now this is the graph of modulus function. If you observe this graph, it is above the x-axis. This line and this line. This curve is the graph of the modulus function. If you observe the range of this modulus function is positive real numbers. Okay, my dear children? Right. Now the next type of function is signum function. Signum function. The function f from R to R defined by f of x is equal to 1 if x is greater than 0. F of x is equal to 0 if x is equal to 0. F of x is equal to minus 1 if x is less than 0. If a function f is defined like this, then the function is called the signum function. It can be defined like this also. F of x is equal to mod x by x comma x is not equal to 0, and f of x is equal to 0 if x is equal to 0. This is also signum function. The domain of the signum function is R, and the range of the signum function is the set minus 1, 0, 1. Only 3 elements are there in the range of the signum function, and this is the graph of the signum function. See here y is equal to 1, here it is parallel to x axis, here y is equal to minus 1, here it is parallel to x axis. Okay, my dear children, understood this function, signum function? Right. Now the next type of function is the greatest integer function. The function f from R to R defined by f of x is equal to step x. This is read as step x. Remember this point, my dear children, how to read this function. Step S-T-E-P, step x. X belongs to R, assumes the value of the greatest integer less than or equal to x. Such a function is called the greatest integer function or step function. Let us see some example. Let us take some example to understand this function. Step minus 3 value is minus 3. Step minus 3.1. If you observe this number on the number line lies between minus 3 and minus 4, then left side integer is considered as its value. So minus 4. Minus 3.72, it lies between minus 3 and minus 4. So the left side number is minus 4. So its value is, the function value is minus 4. Step 5 is 5 only. Step 5.1, it lies between 5 and 6. Then on the number line, what is the left side number? 5. So the function value is 5 only. Step 5.237, this number lies on the number line between 5 and 6. So what is the left side number? 5. Left side integer is 5. So its value is 5. Understood this greatest integer function, my children? Remember this definition. This is very important function. So if you draw the graph of this greatest integer function, see here 0 to 1, 1 to 2, 2 to 3, 3 to 4, minus 1 to 0 to minus 1, minus 1 to minus 2, minus 2 to minus 3, like this. If you observe this graph, it looks like steps. Here one step, second, third, fourth steps. So it is also called step function. Okay, my dear children. And moreover, if you observe the range, the function values are all integers. It may be positive integer, it may be negative integer, or 0 also. Step 0 is 0. So the range of the greatest integer function is integers, set of integers. Remember this point, my dear children? Okay, right.